And we're ready here for Math with Mr. Waterman 2.1. What is a power? Well, that was a nice little intro. And, well, today, what is a power? When texting or Facebooking people, we use the strangest language. Yet, everyone seems to be able to understand it. You guys know what LOL means. We laugh out loud. It is definitely overused. We also know that THX. Well, what is that actually? It doesn't spell anything. Well, it means thanks. And we also have TMI, too much information. We also have WBS. Well, I don't know how many people use that anymore, but right back soon. We also have SWDYT. So what do you think? Okay. And we also have TTFN, ta-ta for now. And someone, oh, that's just someone. And then POS, parent over shoulder. Who knew? Can you think of any other abbreviations that you guys use while texting or Facebooking? Well, why do we use these shortcuts? Well, they're faster. They are shorter. And we didn't used to have unlimited texting plans, so we had to make sure that we got our message in as fast as we could and as short as we could. We had saves time, and it's more efficient. Right? It's also easier. It may not be easier, though, to understand what people are actually saying. Well, it turns out that math is pretty hip and happening because mathematicians also use shortcuts, and they've been doing it forever. All right, so one such shortcut is the exponent. It's just like texting, but it's for math, so that's awesome. All right, so an exponent is a shortcut for repeated multiplication. All right, so let's take a look at 6 times 6 times 6. Well, instead of just saying 6 times 6 times 6, we're going to write 6 cubed. All right? This is like saying 6 to the power of 3. All right, that's pretty awesome. Now, there are 3 new terms we're using when we use this shortcut, or this shortcut when we're using exponents in math. Base. Well, this is the number we keep multiplying. All right, so in this case right here, we had our base was 6. Our exponent is the 3 in this case, and it's how many times to multiply the base by itself. And then finally, the power is the whole expression. All right, so let's get a quick example here. Let's go 4 to the power of 5. Well, we've got our base, which is the 4. We've got our exponent, which is the 5. The whole thing is called a power. Well, what does it actually mean? Well, it means 4 times 4 times 4 times 4 times 4. Huh, interesting. I don't want to write out 4 times 4 times 4 times 4 times 4. I would rather just write 4 to the 5th power, or 4 to the exponent of 5. Okay, let's move down a little bit. And we have powers can be rewritten as a repeated multiplication and in standard form. So we have our power, then we have repeated multiplication, and we standard form. And we all know how to do standard form. So we've got 3 to the power of 4. Well, what does that mean? It means 3 times 3 times 3 times 3. Well, what does that actually equal, which is standard form? And 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Next, well, we've got a repeated multiplication. 2 times 2 times 2 times 2 times 2. That's like saying 2 to the exponent of 5. And when we multiply that out, we get 32 as our standard form. Now, let's go back from standard form to repeated multiplication. Well, what number multiplied by itself will get us 125? Well, it turns out that 125 is just like saying 5 times 25, and 25 is just like saying 5 times 5. Well, there is our repeated multiplication. 5 times 5 times 5. How do we write that in power form? Well, we go 5 to the exponent of 3. Next, we've got 7. 7. What two numbers multiply to 7? Well, it turns out 7 and 1. Well, 7 is just by itself. And then we get 7 to the exponent of 1. That just says 7. All right, so any number to the exponent of 1 is just the number itself. Now, in the following, we're going to identify the base and then evaluate. So our base in the first one is -3. Now, the brackets are very important in this one. What is that saying to us? Well, it's saying -3 times -3 times -3 times -3. Well, we have a negative times a negative, which is going to give us a positive, right? And then we're going to times a positive by a negative. It's going to give us a negative. And then a negative times a negative is going to be a positive. All right, so our final value will be positive, and we get 81. All right. Now what we have is we have -3 to the exponent of 4. Well, it turns out the negative is going to stay out front, and our base here is 3. The negative is just out front. So then we find out that we have negative, and then we got 3 times 3 times 3 times 3. And our final answer is always going to be negative. Next, we've got a negative with a base of a negative to the exponent of 4. Well, our to be 3, and our value, we have negative out here, and we've got negative, and then we've got 3, and we've got another negative, and then we have 3 times 3 times 3 times 3. Well, two negatives make a positive, and we end up with 81. All right, now, can you use your calculator to find the next powers? I'd like you to try these out, please. You might have a different button on your calculator. You might have an X with a Y on it, right? You almost might have one with a little arrow pointing up, or you might have a Y with an X button, all right? I'd like you to try and find the what these actually equal in standard form, and make sure you put in the brackets, all right? And I'd like you to also fill in what your calculator key looks like. All right, so we've got some special cases. Powers with the exponent of 2, so that's like 5 squared, mean 5 times 5, all right? And we can draw this. We have a side of 5 and a side of 5, and inside we get 25. So this is squared. And next we have powers with the exponent of 3. Well, that's like saying 2 to the exponent of 3, and that means 2 times 2 times 2, and this would be like drawing a cube. And we have 2 by 2 by 2, and that's going to equal 8 units cubed. Just like this one would be 25 meters squared if they were all meters. All right? And that would be cubed. All right, finally, can every integer other than 0 be written as a power? Explain? Yes. Every integer other than 0 can be written as a power. So what does that mean? Well, if I take 2, well, if I want to write, this is in standard form. If I want to write it as in power form, 2 to the exponent of 1 is still the exact same number. if an integer can't be broken down to repeated multiplication, it can be written as itself to an exponent of 0. Okay, we'll try one more. 4 can also be written as 4 to the exponent of 1. So, if an integer can't be broken down to repeated multiplication, it can be written to an exponent of 1. All right, we'll see you in class.